Hello and welcome to the Math District. In this video, we will see how to get information from a graph. So here we have the graph of the function called f of x. Looking at this graph, we notice a closed dot to the left and an arrow to the right. The closed dot indicates that the graph does not extend beyond this point and the point belongs to the graph. But the arrow indicates that the graph extends indefinitely to the right. The first question we will answer will be find f of -3. In other words, what is the value of the function when x is -3? In the rectangular coordinate system, the horizontal axis is the x-axis and the vertical axis is the y-axis. So first we will locate -3 on the x-axis. So from the origin, we will move 3 units to the left. 1, 2, 3, and here we will have -3. Now we will find what is the corresponding y-coordinate of the point on the graph. So from -3, we will move 4 units up, and the corresponding y-coordinate will be 4. So we can say that f of -3 equals 4. The second question is find f of 0. So in other words, when x is 0, what is the y-coordinate of the point on the graph? X is 0 right at the origin, and to find the point on the graph, we will move down 2 units, 1, 2. And this point has the y-coordinate -2. So we can say that f of 0 equals -2. The third question is find f of 2. So let's locate 2 on the x-axis. From the origin, move 2 units to the right. And then to find the corresponding y-coordinate on the graph, we will move 1 unit down. And the y-coordinate here is -1. So we can say that f of 2 equals -1. The fourth question is to find f of 5. So from the origin, let's count 5 units to the right. That is 1, 2, 3, 4, 5. So here we have 5 on the x-axis. And then to find the corresponding y-coordinate of the point on the graph, we will move 2 units up. 1, 2. So here the y-coordinate is 2. So we can say that f of 5 equals 2. In question 5, we have to find the function's domain. The domain of a function represents all the values of x a function can take. To find the domain from a graph, we have to look at the graph and see how far this graph extends to the left and how far extends to the right. We see that the leftmost point on x-axis is -3, but as we go to the right, we see that the graph extends forever. So we can say that the domain represents any number from -3 to +infinity. To show that -3 is part of the domain, we will use a bracket and start with -3, comma, and then use the infinity symbol, and on the side where we have infinity symbol, always use a parenthesis. On question 6, we have to find the range of this function, and the range represents all the values of y a function can have. On the graph, we have to see how far down this graph extends, and then how far up extends. From the graph, we see that the lowest point on y-axis is -2, and the highest point is 4. So the range includes all the numbers from -2 to +4. To show that -2 is part of the range, we will use a bracket and write -2, comma, then 4. And to show that 4 is also part of the range, we will close with a bracket. In question 7, we have to find the x-intercepts of this graph. The x-intercepts are the points where the graph crosses x-axis. This graph crosses the x-axis at 2 points. The first point has the coordinates -2, 0, and the second point has the coordinates 3, 0. So we found the x-intercepts, and they are -2, 0 and 3, 0. On question 8, we have to find the y-intercept, and this is the point where the graph crosses y-axis. The point where the graph crosses y-axis has the coordinates 0, -2. So we found the y-intercept, and the y-intercept is 0, -2. On question 9, we have to find the values of x for which f of x is less than 0. A function is less than 0 when a portion of a graph is below the x-axis. So, in this graph, we see that this portion is below x-axis. So the question is, for what values of x this graph is below x-axis? And we see that the values of x are the numbers between -2 and +3. So we will include only the numbers between -2 and +3, but we will not include -2 and we will not include +3, because at -2 the function is 0, and at +3 the function is 0, but we need only the values of x for which the function is below 0. So we will use parentheses to show that neither -2 nor +3 are part of the interval. We can say that the values of x for which the function is negative are all the numbers between -2 and +3. On the last 3 questions, we have to find the intervals on which the function is decreasing, increasing, and then constant. As we move on the graph from left to right, we notice that the graph goes down. That means the graph is decreasing. From here, the graph goes up. That means the graph is increasing. And then from this point, we see a horizontal line. That means that the graph here is constant. First, let's find the interval on which the function is decreasing. In other words, we have to find all the values of x on which the function is decreasing. We can see that on the interval between -3 and 0, the function decreases. And when writing the interval on which the function is decreasing, we always use parentheses. So we will have the interval between -3 and 0. Now we notice that from 0 to +4, the function increases. So the interval on which the function is increasing is 0, 4. Again, using parentheses only. Now on the interval from 4 to +infinity, the function is constant. So we can say that the interval on which the function is constant is 4, infinity. So by analyzing this graph, we obtained a lot of information about this function. I hope you liked this video. Thank you for watching.